The next question that you can ask about a function that has these asymptotes has to do with not like infinity up and down, but rather infinity left and right. So the way that we ask that question is we ask, what is the limit of f of x as x approaches negative infinity, and what is the limit of f of x as we approach positive infinity? Okay, so saying x approaches negative infinity, like again, I've mentioned this a couple of times, but if we know that this is the x-axis, the left and right horizontal asymptote or axis, then the left side of it is where it is negative, and the right side of this is where it is positive. None of this is groundbreaking. You know all of this. So as x approaches negative infinity, that just means like way over that way on the left side of the graph. And then the same thing is true as x approaches positive infinity. That is just asking about way over on this side of the graph. So looking at this, like as you get closer and closer and closer to negative infinity, the graph is approaching -2. And so the answer for this ends up just being the horizontal asymptote. In fact, that is what a horizontal asymptote is. It is an algebra 2 expression of a calculus concept, a way of dealing with infinities that algebra 2 students don't even have yet. And so instead, like we give them asymptote as a vocab word, when in actuality, like the math terminology of a limit is another way of thinking about it that has broader applications. It's pretty cool. Same thing on the right, if you think about it. On the right, it's approaching it from the top instead of from the bottom, but it's still approaching the exact same number. It's approaching -2. This is how you express your infinite limits as x approaches negative infinity and as x approaches positive infinity. And you will do this only in situations where there is a horizontal asymptote. I think that's all for this one.